So we're going to talk about what you guys definitely learned in Gen Chem and what was on the material that was on the pretest this morning. So the first thing that we're going to talk about is making solutions, getting from grams in a volume to molarity, and the second thing is how to make serial dilutions. And then we're just going to briefly touch on significant figures. So, one of the questions on this morning's exam was what is the molarity of a 500 milliliter solution containing 25 grams of table salt? So the way I think one of the main concepts here was you need to know what molarity is. And so molarity is moles per liter. And you should have that down cold as soon as possible. You're going to need that a lot. So basically what you do is you just take 25 grams of table salt and divide it by the molecular weight of 58 grams per liter, or sorry, grams per mole, and then you multiply it or divide it again by the volume that you're making the solution for. So then you get your units to cancel, grams, grams, and then you end up with moles per liter and 0.2 molar sodium table salt solution. The next question, or one of the other questions is what volume of a 1 molar hydrochloric acid solution is needed to make 1 liter of a 0.01 molar hydrochloric acid solution. So what we need here is M1V1 equals M2V2, and what that means is the molarity of the initial solution times the volume of the initial solution is equal, because the moles are equal, to the molarity of the dilute solution times the volume of the dilute solution. So what we're looking at here, what we want to find is V1. So how much of the first solution do we need to add to get to the second solution? So if we have 1 molar hydrochloric acid times some volume that we don't know, that equals the second molarity, 0.01 molar times 1 liter. And so when you isolate the variable on one side, you find that it's actually equal to 0.01 liters, which is 10 milliliters. So we need to add 10 milliliters of the concentrated hydrochloric acid and dilute it to a liter in order to have a 0.01 molar solution. The last thing is significant figures. So I have put the significant figures in red and the not significant figures in black. So here we have 307, all 3 digits are significant. Here we have 23103, all of those are significant. Here we have 0.000230, and these 3 zeros are not significant because they're just placeholders. They just give you an order of magnitude. These 3, however, are significant because they're the measurement that's got 3 significant digits. I don't know. So then it's the same type of thing here where you have 4.75 times 10 to the negative 5th. So it wouldn't matter if it was times 10 to the positive 5th, negative 5th, all of those, any way you slice it, those zeros that times 10 to the negative 5th represents are not significant because they're just order of magnitude. So here is the same thing. If you have 100, that's not significant, but if you have 100 with a decimal point, then you would have 3 significant figures. And if you added more, then you would have 100 with 5 significant figures. So when you start doing math with these, you might be adding something that you weighed on the analytical balance and something that you weighed on the top loader balance and have different significant figures. So here's how it works. When you're adding and subtracting, you need to have, your answer will have the same number of decimal places as your digit that contributes, or as the number that contributes, it has the fewest decimal places. So here, 15.25 has 2 decimal places, so your answer has 2 decimal places, and this 24 is not significant. For multiplying and dividing, it's a little bit different. And so if you multiplied these two numbers together, you actually would still have 4 significant figures, but it's because the answer is the lowest number of significant figures. So the answer will have this same number of significant figures as the contributing number that had the fewest number of significant figures. So we're going to cover these probably in more detail later on in the semester, but this is something that you want to start thinking about now. So when you're, you added you multiplied something and you end up with a number like in your calculator, probably not all of these are significant, so you shouldn't be giving them to me in your homework. So this is definitely something to pay attention to. All right, that's all I have for you.